All right, we started with linear inequalities with only one sign, then we graduated to linear inequalities with two signs. Now we're gonna solve quadratic inequalities, and then I'm gonna introduce the infinity table, which is how we solve it. Now this is the fun part, and this is pretty much as difficult as it gets. There's one more level after this, but that's pretty much it. So right now we got x squared plus 3x minus 4 is greater than 0. Or another way to read it is x squared plus 3x minus 4 is positive. That's key. But here, just like with linear inequalities, we started out by comparing it to linear equations because we like to build off what we know, and we know equations. We're gonna start off with quadratic equations to compare it to quadratic inequalities, right? So first of all, that's a greater than sign. Let me change that to equal, yeah. So the first thing we want to talk about is we're not isolating the variable x like how we do with linear inequalities. Here, for quadratic inequalities or quadratic equations, quadratic functions in general, you want to do the factor. You want to get the factor form of the quadratic function. Here we have it in the polynomial form because you see that x squared. You want to factor it out. Now, I can do a whole video on just how we factor and how we factor quadratic functions, but here I'm gonna skip that. I'm gonna walk you through it, but I'm not gonna go into detail like how I would if it was solely about that. All right, the first thing I'm doing, I'm changing that middle term from 3x to negative x plus 4x. And negative x plus 4x is equal to 3x. So I haven't changed the function. It's the same thing. I'm just writing it in a different form, and that's so we can factor it out cleanly. Now, whatever we do to the equation, we're gonna do to the inequality because we're comparing it. So we got x squared plus 3x x squared minus x plus 4x minus 4 is greater than 0, or you can say it's positive, right? So here I'm gonna do like a little imaginary separation with the function to indicate the two sides that are gonna be factored. So here we got the x squared minus x is gonna be factored, and the negative 4x minus 4 will be factored. Now the greatest common factor in x squared minus x is x. And when we take x out of x squared, that just leaves x. And when you multiply it back, you get back x squared. That's how we know it's correct. Now we take the x out of negative x, that's gonna leave negative 1. Multiply it back. X times negative 1 gives me negative x. So we got the same thing, didn't change nothing. Now we're gonna factor out the greatest common factor, which is 4. So taking 4 out of 4x is gonna give me x. And taking 4 out of negative 4 is gonna give me negative 1 equals 0. Now me personally, I like to triple check, make sure I factored out perfectly, make sure when I multiply it back, I get the same quadratic function from where we started. Now whatever we do to the equation, we're gonna do to the inequality. All right, now we wanna factor out that x minus 1 factor because that's the greatest common factor in this form of the quadratic function we got now. So we take that x minus 1 out of the first term and we get just x. Multiply that back out, you can see we get the same thing, x times x minus 1, same function. Now take the x minus 1 out of that second term and we get just plus 4. Multiply it back out, x minus 1 times 4, 4 times x minus 1. We got the same thing, it's clean. And of course, whatever we do to the equation, we're gonna do to the inequality. Now we're reaching the end of solving the equation, the quadratic function with the equation. Here, it's either x minus 1 is gonna make the function 0, or it's gonna be x plus 4 is gonna make the function 0. And we gotta find the solution, which is pretty easy, it's just one step. What makes 0? You subtract, or you add 1 on both sides. You add 1 on both sides so that the ones cancel out, and you get x is equal to 1. And then on the other side, you subtract 4 on both sides, So the positive 4 and the negative 4 cancel out. You get x is equal to negative 4. And that's the solution. If we plug in 1 into that function, we get 0. Or if you plug in negative 4 into that function, you get 0. We're done. Here, for the inequality, we're not nowhere near done, right? Because the solution set is much bigger than the solution set to the equation. So now we're about ready for the infinity table. But before we get there, let's complete the inequality. Whatever we did with the equation, we're going to do on the other side with the inequality. All right, so now I'm highlighting the x equals 1 and x equals negative 4, and I'm labeling them the zeros of the function, quote unquote, the zeros of the function. And this is going to be a key component to writing out and constructing the infinity table. Remember, for the inequality, we're looking for the solution set that makes the quadratic function greater than 0 or positive. So these zeros are going to be kind of like the critical points for which we get the intervals that let us know what's going to be the solution set. So here, we're going to start drawing the infinity table. Now, the first thing we draw with the infinity table is the infinity signs, right? So we're accounting for all real numbers between negative infinity and positive infinity. That's why it's called an infinity table. Never mind my OCD. I don't know why I'm such a perfectionist. All right, so here we draw the negative infinity, right? And then we draw the positive infinity. And then from here, I just draw two vertical lines, a vertical line coming down from the negative infinity, and then a straight vertical line going down from the positive infinity. Then the next step, I draw a horizontal line. Now we're gonna start to make it look like an actual table. All right, bet. Now, at this point, we wanna make the rows for the table. Now, the number of rows are gonna be each factor and the product of the factors. So that's 3 because it's 2 factors, and then the combination of their product is gonna be the third row. So now I'm drawing 3 rows for the infinity table. Now this next step is purely aesthetic and based off just the feeling and emotion for me personally of the infinity table. And it helps me to engage with the storyline that we have with solving the quadratic inequality. So here I'm just writing that these are real number lines, remember, because we're doing everything from negative infinity to positive infinity and everything in between. And I'm indicating with the arrows that these are real number lines, right? Again, you don't have to do this. I just do this, make it look cute or whatever, but it's really the storyline for me. Everything's a story for me because that's how we get an understanding. Now, this is the point where we write the zeros of the function in order from least to greatest. So you see I'm writing the negative 4 first, drawing that vertical line, and then the positive 1, draw the vertical line. Now you can really see it's looking like a table. I bet. At this point, now we're going to start putting the factors and the combination, the product combination of the factors in the rows, right? So one of the factors, x plus 4. The other factor is x minus 1. Then, of course, you got the product combination, which is x plus 4 times x minus 1. And now we got that first column pretty much done. Now we're going back to incorporating the zeros of the function. All right, so for the x plus 4 factor, right, the thing that makes that 0 is negative 4, right? So we're on the number line with the x plus 4, and we say, okay, at negative 4, we put that dot, which is going to be open because it's a greater than sign, not a greater than or equal to. It's going to be an open dot under negative 4. Then for x minus 1, it's positive 1. So we go across the number line, line it up with the positive 1, put that open dot there. Boom. All right, so here's the rule. Anything to the left of the dot is going to be a negative sign. Anything to the right is going to be a positive sign. Okay, so now for the x minus 1, we got 2 negative slots and 1 positive slot to the right. Now, the product combination is just that, the product. But we're just multiplying the signs here for the infinity table. So for the second column, we got negative times negative gives you a positive sign. Then for the second one, we got positive times negative gives you a negative sign. Then you got positive times positive gives you a positive sign. Now remember, the inequality is for the function to be positive. We only care about it being positive, greater than 0. So the ones that we care about are the positives, not the negative, the positives. So here I'm gonna write my checks and X's. Anytime I see a positive, I draw that check. When I see a negative, X, because we don't want that. Now we can write our solution set. So we're comparing the top of the table to the bottom. Within that checkbox, we got the first interval, which is negative infinity to negative 4. Then with the second checkbox, we got the interval of positive 1 to positive infinity. This is the solution set. We're saying that all values of X in between 1 and positive infinity is going to make that quadratic function a positive one. And the same thing, everything in between negative infinity and negative 4 is going to make that function a positive function based on the signs that we get from the factors. All right, we're approaching the last step. I'm drawing that big U to say we're including both intervals. So it's the union of these two intervals that's the solution set. So we read it like the solution set of X is the interval negative infinity to negative 4, union positive 1 to positive infinity. Now teachers might want a different expression of the answer. So to say the interval negative infinity to negative 4 is the same as saying all values of X less than negative 4. Then for the union, that's the same thing as saying or, and then we write X is greater than 1 because that's the same as saying all values of X between positive 1 and positive infinity. Now we got our solution. It doesn't matter which way, it just really goes on the preference of your professor of how you want to write that solution, but they mean the same thing. But yeah, this is the infinity table, and we're gonna do a few more examples just to get acquainted with it. It really doesn't take as long as I did it here. I'm just, showing the instructions. But once you get a good rhythm, again, repetition is key so that you have the mechanical memory of it, you'll be fine. Like, subscribe, and comment for what type of problems you want to see solved. Peace.